How do you even find a mine? The landmass of the Earth is 150 million square kilometers, with valleys, mountains, basins, deserts. There are roughly 1,000 Earth observation satellites in space. And since antiquity, cartographers have canvassed the globe, describing the nature, the fauna, the flora, and producing ever more accurate maps. So you might think, we know how the Earth looks like, and it's easy to find a mine. But when looking at where mining is taking place, it is at very remote corners in seemingly random locations. It is finding a needle in a haystack, and this is modern-day treasure hunting. This modern-day treasure hunting is called exploration. It comes at a great risk and also at great costs. Out of 1,000 exploration projects, maybe one mine may materialize in the future, but if you find this needle in the haystack, then the rewards may be huge. There are a lot of advances in technology, satellite, geological surveys, big data. However, nothing can compare to have boots on the ground. What does it take to be an explorer? What does it take for people to go into these kind of risks? Europe, over a long period of time, had the best geological surveys in the world. However, the interest in the underground faded, so that a lot of the maps that we have to rely on are very much outdated. We see now a renewed interest to tap the riches in the European soil. And we will talk today about technology, risk-taking, and what kind of character it takes to chase such a needle in a haystack and not to run after a white whale. With us today is someone at the forefront of all of this, Peter Vermeulen. Welcome to another episode of the Euromines Mining Podcast, and today we are going treasure hunting. With us is Peter Vermeulen. Peter Vermeulen is an advisor to a private equity fund focused on precious metals and exploration of precious metals in North America and in Europe. And you're particularly interested in everything pertaining to copper, nickel, and lithium. So all kind of materials that are necessary for the energy transition. So what better guest could we have for financing of exploring than Peter? Welcome.
Thank you, Florian.
So tell us a bit, what are you doing?
Yes, we're explorers. So we have been focusing on exploration throughout basically my whole career. And what we do is grassroots exploration. And that means that we work a target up from the ID concept phase to the drill discovery phase. And after the drill discovery, we will assess how big the drill discovery is. And then that's the point where our job is basically done, because we're explorationists. So we are geologists. We're looking for the mineral discoveries. And then we hand it over to the miners.
Okay.
That's a totally different discipline. They are engineers, they are mine builders, and we are the mine finders.
Okay.
Yes, and I've been doing this since I started my professional career in 2006. Always have been investing, but I also realized that you want to be investing in a niche. So because you can, of course, analyze a company like Royal Dutch Shell, but there are 80 analysts covering it, as a matter of fact. And there's so much competition, and I wanted to specialize in something, and that was junior exploration.
Okay.
And one of the reasons for that is also because mineral discoveries can be very rewarding. It's basically a few million investments, but you can find for billions of metal value in the ground. So the potential is huge, and that was one of the original arguments. But later on, there actually was a new argument coming to the floor, and that's the energy transition. Because now we realize that we actually need these minerals for making the world a greener place, because of the intensity of the energy transition and the metals needed for it, the nickel, the copper, the lithium.
So you're a modern day treasure hunter.
Indeed.
You're trying to identify where there is something in the ground. Indeed. And try to understand how large it is and what kind of value can be created from it. Is that more or less right? Okay. So you're one step ahead of mining, essentially. But it's still very closely related to each other.
Indeed.
What is your specialization compared, for example, to mining companies who do also something similar? They're also hiring geologists and they're also exploring. What is your niche that as you described?
Indeed, they are also exploring, but primarily, especially in the last 20 years, they are exploring brownfield, which means that they are exploring surrounding their existing mines. The greenfield exploration, that has been in decline for quite some time now. Actually, the exploration budgets for grassroots exploration, so not near the mine, but in other areas, is at a record low currently.
Really?
Yes. And if you look at the statistics, actually, there's a lot of data available. For instance, in Canada, 84% of all the mines that have been discovered in the last decade were discovered by junior explorers.
Okay.
So this is a very important industry, and also the mining companies, they count on juniors to make these grassroots greenfields discoveries, so that they can buy these discoveries and add them to their mine lives and to their reserves.
So financing is at a record level low for greenfield exploration. Is this only a European phenomenon or is it a global phenomenon?
It's a global phenomenon.
It's global.
Yes.
Okay.
And also, if you look at, for instance, the percentage of worldwide exploration budgets that go to Europe, that's currently 3%.
3%.
So it's very small. And this is really a problem because exploration is the lifeblood of mining. You can compare it to the pharmaceutical industry, where you have biotech doing the preclinical, the clinical, the phase 1, the phase 2 research, and pharma takes the biotech, finds the new medicines off their hands, and will market it and will finalize the studies. So pharma counts on biotech to come up with new medicines. And the parallel here in mining is that the mining industry counts on exploration to find new mines for them. So it's very important. And you also have to take into account that from the ID concept phase to the exploitation, so the real mining phase, the average is about 16 years. So if we are going to need many minerals in the next couple of years for the energy transition, well, the time is already now. Well, it's actually already past us. So you have to continue investing in exploration because of the long timelines.
Okay. So the risks are quite high. You are looking for something, you're not sure whether you can find it or not, but then also the rewards are quite high. It's like chasing a white whale, isn't it?
It is. Yeah. The odds of success, the average actually in this industry are 1 in 1,000. Well, at least that's what the Rio Tinto, the large mining company, says. So it is very risky. So how you can cope with these risks, that is to do it on a very large scale, do it systematically, and very important, falsify and not verify. Okay. That's one of the key values within our firm. And that means, that means that you want to kill projects as soon as possible, because the costs in exploration, they escalate. So initially the desktop studies and the initial mapping and recon work in the field and the initial sampling, that's not the most expensive part. The most expensive part is the eventual drilling. That's the most expensive part of exploration. So you want to falsify. That means that you want to cycle through as many projects as possible and kill them as soon as possible, find the fatal flaw while the costs are still low. And in that way, you can increase your odds of success. Just to give you an idea, within our firm since 2018, we have looked at 329 projects. And from those 329 projects, we checked 219 projects in the field in 21 different jurisdictions. And we have eventually drilled 4 targets of those.
Okay.
So you need this systematically approach because otherwise it's very hard to actually find a mine. Indeed. And from these 4 drill campaigns that we undertook in the last 3 years, we had 3 drill discoveries. So it looks like we are beating the odds currently, but we think that's the result of our process and our risk management.
All right, understood. You said 3% of global exploration finance is going to Europe. Is this a trend that is more or less stable, or has it declined over the last, let's say, 10, 20 years?
That I don't know. I haven't seen the trend. All I see is the absolute number, and I see it's very low. And I think there are many reasons for that. But one reason, unfortunately, is that there is no level playing field here in Europe. And what do I mean by that? Is that most capital for exploration goes to Australia and Canada. And that's because there are several incentives for exploration, because they see the importance, the need for new critical raw materials to be found. So there are federal incentives and there are provincial incentives and all sorts of fiscal stimulus, which in the end means, for instance, in Canada, that for every exploration dollar that a private company invests in looking for these critical raw materials, the dollar is doubled. So you can spend $2 effectively because of these incentive schemes. But in Europe, unfortunately, there's not such an incentive. So if you, as an exploration company, have a choice between exploring in Canada or in Europe, and you have a project that has the same merit, then you would, of course, choose Canada. Actually, in some countries in Europe, there's a negative incentive for looking for critical raw materials because the VAT that you pay on exploration cannot be reclaimed. So it's even negative in some countries. And I'm quite hopeful that this is going to change with the new perspective, with the Critical Raw Materials Act, and the importance of finding these energy transition metals in the future. So there's definitely winds of change happening now.
So let's circle back to what exploration actually is. I'm coming back from Austria and I visited 2 mines. One was an iron ore mine that is mined since the 8th century. The other one was an underground mine for industrial minerals, for magnesite. So I do understand iron ore, if it's open pit, you maybe see some kind of oxidation, it's orange, you start digging, you find something. Mineral underground that has been mined since, I think, 100 years, or a bit more than 100 years. I think it's much, much more difficult to find, especially when you're in the middle of valleys and mountains and you don't really know what there is. How do you even start to look for something?
Indeed. Well, you can work from the known or you can work from the unknown. If you work from the known, you look at historical occurrences. Many countries have a geological survey that keep track of all the historic mineral occurrences. There are databases. Sometimes there are previous operators that left a certain project, but we're not using the techniques that we have at our disposal right now. So there are many desktop studies that you can do to find something that is of interest, or apply a new theory to a known project. I can give you an example of this later. Or you can work from the unknown, and then you look at your geological studies and you come up with a concept and find scientific proof for that, and then test it in the field. And for instance, in Norway, we have worked from the known because there was a historic occurrence in the north of Norway, about 40 minutes drive from Bøde, which is the very beautiful town in the north, in the Nordland province. So there was a historic occurrence of a copper mine. There's actually a very small historic tunnel, an adit, from where they mined historically, this is over 100 years ago, where they mined copper and cobalt actually. So this was in the database. So our geologist went to the site and see it and checked referenced with what was known about the historic
Mhm.
occurrence in the literature.
Okay.
But they actually, it was actually discounted as a small occurrence with no potential. But our geologists thought otherwise based on what they saw in the field and from the mapping and the structural analysis that they did, and from entering the adit actually and sampling the adit
Mhm.
and seeing all the rich minerals that were there and the minerals that were there on a small waste pile and things. So that was so interesting that we staked those licenses in Norway and then moved on to do systematic sampling. And we discovered that actually this historic adit was part of a 6.5 kilometer trend of copper in soils. So, and we've done trenches, we've done all sorts of programs to identify this target. So this took about 3 years from the initial study to eventually in 2022 drilling
Mhm.
the prospect, and we found a lot of copper.
So this is from the known.
Yes.
What is the preferred method? I assume it's rather from the known side. How long back do you go in the records when you look at it from the historical level? Is it going back to, ancient Rome and Latin texts that maybe talk about sulfides occurring somewhere?
Yeah, whatever is available. But the good thing nowadays is that more data comes available because of AI and data science. Just to give you an idea, there have been a lot of historic reports handwritten, so they are not digital.
Yeah.
But now with the new techniques, these reports from the 60s and the 70s can be digitized and can be searched. And now with AI, we can really come up with very advanced prompts, which are basically search prompts of 2 pages. So very geologically driven, focusing on analogs of new projects compared to existing mines in operation, and all sorts of keywords. And now we can actually look into these historic projects. We are doing this now in Canada, and it already is giving us very interesting targets and results.
You also mentioned the National Geo Service and their maps that are necessary to look into. So my impression is that in Europe, most of those maps are dating back to the 50s and 60s or 60s or 70s, but really a long, long time ago. What is the value of these kind of mapping for modern exploration? Have we missed a little bit the train here by not looking further or deeper?
It is very, very valuable. Indeed, it's the data that they provide is very helpful. And fortunately, some of these geological surveys are now getting more budget as well because they would like to do more. No, they are always very constructive and trying to assist private parties as well. And they are really interested in having parties come to their country and find new projects and find new mines. So it's very helpful.
So for the technologies that are used, you mentioned desk research, document research, AI, pre-existing knowledge on which to build on. What else is necessary to discover something new?
Boots on the ground.
Boots on the ground?
Yeah, definitely.
So you can't.
No,
you
cannot do this from your computer. You have to go into the field.
Okay.
And you have to do the mapping. You have to get a sense of the environment, the surroundings, the communities. We have a full-time sustainable development officer, even though we are not miners, but we have a sustainable development officer who engages the community from day one. So we want to be a good neighbor. We want to have a very good rapport with the communities. And we want to have a very constructive dialogue. And we are doing that from day one. So that you can only get a sense of what's going on in an area by going there.
Okay.
But the mapping, the structural analysis, the geologists going into the field and making notes of everything that they see, that's very important.
How long are they in the field? I remember I saw a site very, very far off anything. So someone must have passed by or seen it from above to say, okay, there might be something. How do I even get to this point? The world is very large.
Yes, indeed. No, you have to narrow the targets down. So you have to start somewhere. But in the beginning, the recon, lots of distances can be covered. But most areas where we explore, there is no outcrop. So you can actually not see any rock.
Okay.
Because if there would be like a type of rock sticking out of the ground, screaming copper, for instance, it would have already been found. So outcrop is most of the times quite limited. So you need very subtle details, and you need to do a lot of different methods to zone in on areas. And geophysics can, of course, help with that. Geophysics means looking at depth. So with sensors, you are assessing, for instance, the conductivity of the rock or the magnetic features, and that data can give you hints of what type of rock will be at depth. So is it mineralized rock or not? Because mineralized rock will give a different response with these geophysical surveys as barren rock.
Okay. So also, for example, vegetation might also be an indicator?
Indeed, yes. Okay. Yes, so actually we have done biochemical analysis. So basically taking like samples of spruce and assess those for minerals.
Okay.
So we were using all sorts of techniques, and you have to be very creative and really get a sense of where you're treasure hunting, basically. So you're playing battleship, and you want to fire as many bullets as possible to see where the
this
ships
might land.
Yeah.
Okay. So if you're working in exploration, it means you visit a lot of fascinating places, very remote places, probably. What was the most fascinating one, you would say? Well, you got two.
Our geologists are of course in the field all the time. They're doing all the hard work. My role primarily is the funding, so that they have the funding to do what they do. But of course, I've been on many site visits, and that's always very exciting. For instance, the Norwegian project that I referenced before, we were there in the fall of 2022 when we were actually drilling there for the first time, the initial drill campaign. So there was never drilled before there. And that's very exciting. So we actually went in that historic adit. So the water came up until here. So we went 60 meters inside of that adit. And that was very, very cool because you could see the minerals. You could see the minerals from the tunnel with the flashlight.
Really?
And it was, you saw the chalcopyrite. The chalcopyrite is a mineral that is associated with copper. So when you see the chalcopyrite, you know that it's going to be very copper rich.
Okay.
So we saw that. We saw bornite in the waste pile near the adit. Bornite is even higher in copper. And then we went to the drill site, and actually the first 3 holes that we drilled were barren. So they didn't contain any of the chalcopyrites or any other minerals, because you can see that from the core that comes out of the ground. I will explain later how that works. But we went there, and we were thinking, all right, well, this site visit, I'm not sure if we're actually going to see the goods, because the first 3 holes were unsuccessful after all those years of getting to this level, to the drill discovery stage. But fortunately, when we were there, we hit mineralization. So we actually, the best hole was over 50 meters, an interval over 50 meters of more than 0.5% of copper equivalent. So what does that mean? So the drill rig, the diamond drill rig, will drill into the ground, normally with an angled hole, so not vertically, but with an angle. Yeah. So you have more chance of hitting a structure. And in this case, the average depth of the drilling was 200, 250 meters. And then the rock that the diamond drill rig will get to the surface is like it's like this size. So this is like a diameter of like 20 centimeters. And that rock you can see from the textures and from the mineralization if you have hit mineralization or not. And then when you have the drill core collected in the drill boxes, then you will in the core shack at the sawmill, you will saw the core in half, and then you do the structural analysis, the oriented core, to get a sense of where the mineralization is dipping towards. And then one half of the core will be sent to the laboratory, and the laboratory will analyze the half core for all the minerals. So you will get the results back and you will see the mineral content.
Okay. So, but this is only a very, very small sample of a full deposit. How do you infer the rest of the deposit?
Yes, so this was the initial drill campaign. So 6 holes at the northern edge of a 6.5 kilometer long trend of copper anomalism in soils. So of course, the next step would be to drill south and drill with step outs and just test the whole trend. But that, of course, is a capital intensive step. But we are now at that stage. So we have shown the drill discovery, and now we want to do the follow-up drilling to assess how big it is. And that's the process that eventually will lead to mining, because you will first drill step outs to get a broad sense of how big it is. And then you will drill with shorter distances between the individual drill holes. So you will get more information, and eventually you will do infill drilling. So you will drill like very short holes in a row so that you can do a 3D modeling on what the deposit at depth actually look like. And that's the resource estimation. Okay. That's the next phase. So on the basis of the drill results, you will arrive at a resource estimation.
And how many drill holes are necessary? Is there like...
Depends on the type of deposit. And for instance, the nickel assets that we are looking for a type of nickel, which is called magmatic nickel sulfides. And why are we looking for magmatic nickel sulfides? They are also called tier 1, like class 1 nickel assets, because they are very concentrated. So for a very concentrated deposit, of course, you will need much less drill holes to prove that it's there. So it might be that in the end you would only need between 50 and 100 holes, for instance, if you're lucky. And it's very concentrated. But some of the other mineralization types, they are way more widespread or very fragmented, or they're pinching and swelling. So you will need much more drill holes to get there. But this is actually one of our filters. We are looking for specific type of mineralization settings. So we are looking for the high grade, high margin systems. To give you an idea of how lucrative the magmatic nickel sulfide projects can be, in Australia, in 2012, there was a small company called Sirius Resources. You might have heard of it. And they were valued by the market at a 9 million market capitalization, so very small. And they drilled a project in Western Australia, a magmatic nickel sulfide project, and they hit mineralization. I think it was an interval from top of my head of 4 meters with an average of 3 or 4% nickel. And 3 years later... Is this
large? Is this small?
Well, it's high grade.
Don't tell me anything.
I can give you an idea. Like the average, like the cutoff grade, so the grade that you need to have for nickel, if you have an underground mine now to be economic, is 0.5%.
Okay.
So that means that 4% is...
They're 8 times as high.
Yes, it's very high grade. And 4 meters is not very wide, but it gives you an indication that the grade is there. So this needs to be follow-up. And it's quite comparable, actually, this hole to what we've drilled in Sweden, but that's a sidestep. But 3 years later, when the company was still an exploration company, they were bought out for 1.8 billion by Independence Group, which is now called IGO. And the capex, so the capital expenditure for them to put this project into production was, I think it was 470 million Australian dollars. So quite a low capex compared to some of these other mines, which normally, most of the times, the capex is 1 billion plus, exactly. But as of last year, the cumulative free cash flow that IGO got out of this mine, that they put into production in 2017, was 2 billion Australian. So these systems have a low capex because it's very concentrated and very profitable. And that's because they have a very low operating cost price, because it's not just the nickel that comes with it, which normally is at a high grade, so which is already quite profitable from itself, but you also get copper and you get other byproducts sometimes. So the operational cost price in some years was actually below zero. So that's the type of nickel what we're looking for. And we're not looking for the nickel, the type 2 nickel, which is the low-grade nickel that needs a process to get to the battery-grade nickel level. That's actually what's happening in Indonesia on a large scale, where class 2
nickel pig iron separation. That's
it's the upgrading actually of the low-grade nickel with a process called HPEL. And it's very energy intensive. So that means many coal-fired power stations actually doing the upgrading of the nickel. And if you look at the carbon footprint of such an operation, is of course much larger than a magmatic nickel sulfide mine in West Australia, or a future magmatic nickel sulfide project or copper mine in Scandinavia, where you have, of course, the hydropower, for instance, and much higher standards on environmental fronts.
Is there a premium for these kind of projects?
Well, not yet, but it seems, it looks like this is changing. For instance, the battery passport, of course, is coming, where you will have a label saying, like, where did the battery materials in your car actually come from? There's a lot of talks of distinguishing dirty nickel from clean nickel, so to have different pricing. So we have to see what happens. But what I do know is that we focus on the low carbon footprint systems.
All right. So we started out with potential deposits that are known somehow, either out of records, maps, or otherwise. How would you go about of a project where you're simply looking out into the blue, essentially? How does this work? How does a land that hasn't been recorded, that hasn't been mapped, become interesting suddenly?
Well, we need some indication. And otherwise, where do you start, indeed? So there has to be a clue. And that can be...
What would be such an indication if there is no record? Let's take such a...
Yeah, it can be also word to mouth from prospectors and IDs that they have. But we know, like, there are broad maps on geological potential, so you can already, that some countries or some areas are not very interesting for certain metals. So you can already filter based on that. But if to give an idea, like for instance, for lithium exploration, satellite imagery can help, because you can spot, you could spot pegmatites, and pegmatites, it's a white rock, and sometimes if there's lithium in the pegmatites, there's a mineral called spodumene in the pegmatite. So I don't think our geologists can see the spodumene because that's quite subtle from the satellite, from the satellite imagery. But they can see the pegmatites, and if the pegmatites are in a province that is prospective for lithium exploration, that can be a start. And then you go into the field and check those pegmatites that you have seen from the satellites and see if they are spodumene rich. So that could be an example for lithium, how you would go about if you don't have any clues.
Has there ever been a finding where you would say, okay, you would have never guessed this would be possible in this area?
Well, yes, of course. Like there are examples of companies looking for gold and finding nickel.
Yeah. Okay.
And when we have drilled in the past also projects where it turns out there was a byproduct in much higher quantities than what we expected before.
Mm-hmm.
So yes, now there are great stories written about some of these discoveries and how they actually started. And there's also luck involved sometimes too.
Yeah. Are these discoveries then also changing like our understanding of geology and the formation of the Earth, or is it just okay? It's an aberration. We're fine. Continue with our standard model.
No. These are constantly being updated and remodeled. But most of the big systems, like the geological models for them, they are known. Okay. So actually, one expert on big copper systems, worldwide expert, is Dr. Richard Sillitoe. Mm-hmm. So if you open a geological book on the go-to model for copper exploration, so how did they form, what are indicator minerals, how do you go about exploring for those projects? If you open such a book, Sillitoe, either he wrote it or he is referenced. Okay. And he is actually one of our technical advisors, together with Tony Donaghy, who is the nickel expert, a nickel expert. So we have two leading technical advisors on our board. And actually, Richard Sillitoe was twice on our Norwegian project as well.
Okay. So we talked about exploration from the known and exploration from the unknown. Unknown probably much more difficult than from the known. Are there any spots in Europe where you would say we could explore from the unknown?
There are many spots. Actually, Europe is very underexplored, especially compared to other regions, Canada and Australia. So the exploration work per hectare is so much lower than
Canada, this vast country, so many square miles, kilometers.
Well, the whole of Canada, of course. Canada, there are geological features because without them, even in Canada, there are areas that are not prospective for mining. Okay. So, of course, you have to take into account that you have to look in settings that are favorable for mines. For instance, the Netherlands, where I come from, there are no critical raw materials. Yeah, so why would you look in the Netherlands for those? So same goes for Europe. But if you look at geologically prospective belts, Europe is vastly underexplored. Okay. And that's a big opportunity. Just to give you an idea, in Sweden, in the Bergslagen belt, which is about 3 hours drive from Stockholm, we were able to secure over 1,100 square kilometers of prospective ground for magmatic nickel sulfide systems. Okay. We are the first mover there under this idea that this belt, which was always overlooked for these tier 1 nickel settings, but we thought we developed a theory that this actually could be prospective based on, for instance, the age dating of certain rocks. So that was actually from the same age as rocks that are very prospective for tier 1 nickel discoveries. So we developed the theory and we were able to secure all the ground. That was already in 2019 from the top of my head. And now last year in the summer, BHP, the largest miner in the world, of course, they became our neighbor. So they bought about 100 square kilometers of ground. And we are, basically, we have all the other ground in the area. So a thing like this, like securing such a potential prospective belt for the tier 1 nickel discoveries, that's not possible in Canada. That's not possible in Australia.
Because it is already explored.
Indeed. Yeah, it's already known, explored. And of course, you can still make discoveries in Canada and Australia. It happens. But it is significantly grazed over. So you need to do something new. And we are also active in Canada because some of these old projects that have been not explored further.
Mm-hmm.
With new techniques, you can be able to breathe new life into them. For instance, a technique that's only known since the early 90s
Mm-hmm.
is surveying from the bottom of a historic drill hole. It's called downhole electromagnetic surveying.
Mm-hmm.
So that means
How does that work?
Yes, indeed. Yeah, it's already like I'm thinking like this is very technical. So, but how it works is when the drill rig drilled this hole,
Mm-hmm.
got like the got the rock out of it. You actually probe from the bottom of the hole. So let's say 200 or 300 meter downhole. You will probe the response, the electromagnetic response, from depth.
Okay.
So that means you can look deeper than that you would be able to do with geophysics from the surface.
Okay.
So that technique, if you apply that to projects that have not been worked since the 90s, you can actually find something that historic operators could not find because they could not see the response. So, so even in known areas, you can come up with new concepts.
Okay, so but that sounds like Europe is a new frontier for exploration.
Somewhat, yes.
Somewhat?
Yes, because otherwise we would not be able to stake this belt.
But the belt you mentioned,
Sweden.
Does it mean it has been explored for something else before?
Indeed.
Okay.
Yeah, that's very interesting that you mentioned that because, for instance, in Sweden, in the Bergslagen belt where we are active, there are other mining companies active in that belt, but they are mining a different type of mineral setting. It's called volcanogenic massive sulfides, VMS. So everyone always thought this belt is prospective for VMS because there's a VMS mine. There are mines there, historic mines, which was all this VMS setting. But for the magmatic nickel sulfide characteristic, everyone always discounted it. And we developed the theory that it would be prospective because of what I mentioned before. And that changes the whole perspective. So yes, the belt is known, but the belt is not known for the type of mineralization that we are now exploring for, and where other companies are now also putting an interest in.
What would be other belts? I mean, Scandinavia is very well known for its mineral richness.
Yeah.
Would you say in the Alps it's worthwhile to explore?
Geologically, no doubt, it's very interesting.
Okay.
But we are very cognizant of other risks. So we, in our jurisdictional selection, are always looking for jurisdictions that are familiar with mining, that have a clear mining code, that respect ownership rights, where the community engagement, the people are looking favorably towards mining for critical raw materials, for instance, because they're very intimately known with the energy transition, the electrification. Also, we are never exploring in Natura 2000 areas. So if you look at all the selection criteria that we use, a country like Austria is probably going to be difficult to operate in, because of the social license. Of course, well, it's most of the times just too scenic or too touristic, but there are exceptions to the rule, and of course we will need a lot of mines, so also possibly from Austria.
So now that we have the Critical Raw Materials Act and mining is looked upon much more favorably by politicians, do you also believe that for exploration something will shift into the right direction?
Well,
in Europe,
there are pros and cons. The pros is that there is now a clear permitting window for strategic projects, the 27-month limit for the permitting time for strategic projects that are designated as such by the board. So that definitely makes Europe more investable again for mining.
So you think the 3% would maybe shift to 5%?
Well, that remains to be seen, because the strategic project designation is based on scoping study projects and onwards. So there has to be a study of the discovery. So there has to be an estimate of what's already there, or a feasibility study. So a study that says, okay, these are the parameters of a future mine, and this is what it's going to cost and what it's going to bring in revenues. So that means that exploration project cannot get the strategic project designation. And that's something that we would have liked to be in there, because exploration projects are strategic as well, because we need to advance these exploration projects to the scoping study level, because the European projects that are scoping study and upwards, they're already known. And if they're economically viable, they will get financing. There are a contingent of banks and investors and funds that will invest in something that's economically viable designed. The problem is we don't have a pipeline of new projects that can get to the scoping study. And if advanced exploration projects would get the strategic project designation, it will change a lot in the mindset of stakeholders. Because, for instance, if we say that something is very strategic, then it's some geologist and a fund out of the Netherlands saying it. But if Europe is saying it, that a project is strategic, that will change a lot, and that will bring probably such a project faster to the scoping study level. So it's a mixed bag, but we like the 27-month window, and we see that exploration is becoming more and more visible on the essence of it. Because if we are not investing in exploration, existing mines run dry. All the economically viable mines projects that are there will be developed. But what's going to happen in the next few years? Where's the pipeline? Where's the lifeblood? So we are hoping that at least, at a minimum, the Critical Raw Materials Act will bring forward a level playing field, or at least some form of incentive to stimulate the search for these critical minerals. And of course, we understand that, for instance, fiscally, that might be an issue to do a harmonized fiscal incentive scheme or a harmonized grant, but just something simple as co-investing in a critical metals project, where, let's say, a governmental body or like one of these funds that are being set up is going to put 20% of the exploration budget in, where a private party would do 80%, but only when it's spent. So something like this could be easily designed, we think, from the existing funds that are being set up. In this way, those funds will really leverage every dollar, every euro that they put forward in stimulating the CRM exploration. Because for every euro that they would put in this project, €4 will be put on top of it by a private party. So that could be the first step towards leveling the playing field with Australia, with Canada. And that would really increase that 3% global statistic to a level where it should be. And that will, and the Critical Raw Materials Act also, it's very important that that timeline that I mentioned before, from ID concept phase to the mining phase, the 15 years, it will be shortened. And
drastically,
and with stimulating the exploration and accelerating it, and with the 27 months, maybe we can actually achieve the same timeline that Sirius did in Australia, discovering the nickel in 2012, and IGO building the mine, putting the mine in commercial production in 2017. So the 5 years can be doable, and the CRMA is an important step to get there, but there's a piece of the puzzle missing, and that's stimulating exploration.
How does the IRA fit into this picture? Do you see that there is a change in investment flows in exploration to the US or to North America or partners of North America?
It's it's an important driver, but it's an important driver for the midstream and the downstream so far, because I've seen a statistic by Bloomberg that up until now, or up until the time of the study, which might have been a few months ago, 79 billion has been spent on the IRA so far. The majority of that went to battery manufacturing.
And so very far downstream.
Yes, but the statistic, how much has gone to the raw materials? 1.3. So just a little over 1%.
Okay.
So it's small. It's still small. We see some projects in North America attracting funding, but they are also most of the times in the scoping study phase. But there are exceptions to the rule. Yeah. There are some exploration projects in the US getting funding. So it's coming.
Critical Raw Materials Act also imposes a lot of exploration activities now to National Geosurveys to continue with their mapping, to look deeper and wider. Obligations for companies to look into their tailings. How does private exploration fit into this?
Private exploration towards tailings?
No. In the Critical Raw Materials Act, because you said it's not very well covered. However, there is still exploration going on. What does this change for an exploration company?
Right. I think you're hinting towards the national exploration programs. Yes, that's the item on exploration that is in the CRMA, which indeed dictates that member states have to devise a strategy on exploration in the 12 months, within the 12 months that the Critical Raw Materials Act became law, so May 2023. So the way we see member states do this is indeed like increasing funding, for instance, to the geological surveys, or setting up geological surveys, or putting research houses to work in this space. But that might provide additional data, so that could be good, because that will give some more hints of areas that are prospective for mining. But most of that data is already there. We need actors, we need parties that actually are going to explore, so that actually are going to advance this project and drill the projects.
And develop it then.
Yes, because let's say that the timeline from the ID concept phase to the drill discovery phase, well, on average, it's 3 to 4 years. So they will do the first year, like the first mapping and the first data gathering of the first year. But who is going to do the year 2, 3, and 4? So that's where we need a plan for that.
Okay. Could you walk us through the different stages of an exploration campaign?
Yes. Well, first the ID concept phase, the desktop studies. Then we do the first pass exploration. So we go to the field. We also engage with the communities, with the stakeholders. We get a feel for the land. We see how the access is, all sorts of other surrounding important factors. And then we will take soil samples, rock chip samples. So where a geologist with a hammer takes pieces of rock, of outcropping rock, if there's outcropping rock, or we'll take soil samples where with like, you can compare it to like a tulip bulb drill, where you take a sample of soil and then we send those to the laboratory, which will give us the assays later on, like what the mineral content was of that sample. Actually, sometimes we can sample on site, because with the new techniques, you have like a machine called an XRF machine, where you basically zap the sample with the RF, and then you will get directly an indicator of the minerals that are in there. So you can speed up the exploration. So yes, you take samples, you do the mapping, you do the structural analysis, where you describe the different type of rocks that you see and different type of structures. For instance, faults, which are the cracks that can have caused mineralization to be deposited many years ago. So you look for all sorts of clues. And then that's the first pass. And then once you have analyzed the data and have received the laboratory results back, then you see if it's interesting enough to go back, to take more soils, and to eventually maybe also do a trench. So where you take a deeper sample with the permit in hand, of course, and then you will get information over like a longer distance. So you get information over a bigger homogeneous piece of rock, and you look deeper without having to drill, which is, and you can also sometimes do a channel sample where you saw a piece of rock out of the outcropping rock. So all these clues give you information on if there can be a mineral deposit there. And if those results are also good enough, then the next step most of the time is geophysics, depending on the type of mineralization, of course. And then you will get a sense of the response at depth. And that, in combination with the geochemistry, with all the soil sampling, the trench samples, the channel samples, will give you all the layers of data that you need to bring in the truth machine, is what they call it. So
what is the truth machine?
The diamond drill rig, because that's the most expensive part of the exploration, is called the truth machine. And then you will see if all the layering of data, if at depth the deposit is actually there. Because something might look very interesting at surface, and there might be a geophysical target, but it might not be in economically viable quantities at depth. Because that's the goal. You want to find an economically viable mineral deposit.
Okay. Is this then targeting? Is this what you call targeting?
Yes, targeting is basically what you do in the beginning.
Okay.
The targeting is seeing where you're gonna hit those bullets in the battleship game.
Okay. All right. So, and once this is all done, a project is finalized and it's being sold off to someone else. How does this work?
Yes, well, there are different avenues, of course. At one point in time, you can team up with a major mining company who will take the project forward, and the mining company can earn in a certain percentage of the project by funding the project to the feasibility stage. So they assess exploration companies, advanced exploration companies, they assess discoveries that are being made, and they see if such a project is of interest of them to earn into. So there are certain percentages for that. On average, the junior exploration company ends up with 30% of the project eventually, when there is a feasibility study for the project. Of course, you can also sell a project outright to a major or to a mid-tier producer if it's maybe a smaller deposit. Or, well, if the market is very bullish, you might also be able to attract the capital on the stock market or via other large private equity firms. So there are many ways that lead to Rome.
Okay, because that was my other question. Who is funding these kind of projects? There are a lot of risks involved. Payoffs are also very high. But I assume it takes a certain kind of investor who is looking into this.
Yes, you have to like risk.
Okay.
But you have to also be cognizant of risk and what it means, and that you need risk management because the odds are so low. But yes, there's a very big industry in this. You have thousands of companies that are listed on the Toronto Stock Exchange or the Australian Securities Exchange. So thousands, and most of those companies, they have one or on average maybe two projects. And the majority of them, they stick to those projects because they have raised capital on the basis of those projects. So they hang on to those projects. So they verify it and don't falsify. So there are many companies out there that attract capital. They are requesting capital, but are not putting that capital efficiently to work. So lots of money is leaking away to inefficient companies, because a listed company has a lot of other costs. So on average in Canada, for instance, half of the funds raised are not spent on exploration. They're spent on management, marketing, listing fees, you name it. So not much of that capital is actually being put to work.
So is it like a lot of projects are more wishful thinking than actual projects?
Indeed, yes. And of course, it's because the rewards can be so high when you are successful. That makes it very interesting, of course, to tell a story around. It's you have a lot of projects that are not viable, but still trying to attract attention.
So cowboys and gold diggers.
Indeed, yes. No, that's when you have such a shiny metal, then that attracts a lot of bad actors, unfortunately.
Right. So, but my very last question for you: what does it take to work in this field? What kind of person you need to be in order to succeed?
Well, you have to cope with failure, because you will see a lot of failure because of the odds of success. So the 8 projects, the 8 drill-ready projects that we have now, that are the results of 329 projects, also mean that there were 321 projects that we had to distance ourselves from. So you have to be able to cope with that, but also to learn from your mistakes. And you have to be bold. So you have to think big in these projects to come up with these high margin, new ideas, new concepts, and then go big into those stories. And really go for the metal discovery. And you have to take risk. You have to really come up with that discovery. And the discovery is rewarding, but it's also the discovery that we're going to need if we want to secure the raw materials for the energy transition.
So, Peter, thank you very much for your insights. I think it was very, very interesting.
Thank you,
to understand how a mine comes to fruition in the first place. And we often heard this number, 1,000 exploration projects lead to maybe one mine. And now we know why. Thank you.
Yes, and hopefully in Europe.
Hopefully in Europe.
Thank you, Florian.